Hi guys, this is Gourav Nayyar and welcome to the Solid Design Principle series video. The open-close principle which represents O in the solid. This is what we are going to talk about today. We'll get into the outline of the module, what we are going to talk about today. So the outline for this module will include a definition. We will talk about the problem and also work on an example to understand the fundamentals of open-close principle. So let's get into the definition part of it. Before that, I'll let you know from where the term open-close principle has been originated. So this is Dr. B. Nayyar originated the OCP term, which is open-close principle term, in his 1988 book, which was Object-Oriented Software Construction. So the open-close principle states that the software entities like classes, modules, functions you have should be open for extension but closed for modification. So this example, this definition I have got it from Wikipedia, but throughout today's video we would be talking about open for extension and closed for modification. So we'll get better understanding once the video is finished. Any new functionality should be implemented by adding new classes, attributes and methods instead of changing the current one or the existing one. So basic example, I think once we get into the example it will become more clear. So let's dive into the example. So this is the image which I've got it from Google, and it explains open close principle in a very nice way. So this slide demonstrates how the open close principle can apply in a graphic notation. You could see in the picture, the left side you have a guy and the right side you have another guy. So let's try to understand how we could relate the open close principle using this image. So it says here below, if you could read, open chest surgery is not needed when putting on a coat. So what we could see is in the first image, you wanted to put a coat and what you are doing is the open surgery you wanted to do. Okay. Likewise, when you extend your software, you should not need to go and dig around its internals just to change its behavior. So basically you wanted to change the behavior, you should not dig around to the internals of the software. You should be able to extend it by adding to it a new functionality and a new class or a new functions without the need to change your existing classes and functions while still achieving the different behavior. So it's clear. We'll go through the example again. What was happening is you wanted to wear a coat, you wanted to extend the functionality, but what you are trying to do is what this picture says is you don't need to do open surgery. It's just an extension to it. You could achieve this behavior without even digging into the internals. We will go to the Swift code where I will explain how the open close principle can actually solve the problems. So let's understand the problem part and then we'll work on the solution. So let's quickly revise what we have learned up till now. The two terms which I told you to remember throughout this video. The first one is open to extension and close for modification. So assume you have actually built a software and you wanted to add a layer to it, a feature to it. It should be the behavior can be added in the future. And close to modification, when we say the changes to source and binary code are not required. So this should be avoided. So this brings us a question, why OCP? Okay, so assume where you are actually touching the binary code or the source code of that part, the functionality for the new functionality. Okay, so what you will do, you wanted to test the new functionality, but you will end up testing the entire functionality again. So what it ends up onto, the QE effort is more, it's a costlier operation and maintenance overhead increases on the classes. So every time you write a new function or a new feature, you will end up testing the whole set of features again because you are touching the core which might be getting used at any other place. So that's why the OCP, open close principle, is very important. Throughout the video, we are talking about changing the behavior without changing the code. So how can this be achievable? So we can achieve it by relying on the protocols. It is called interfaces in the other languages, and we'll understand it once we get into the demo part. So let's get in. So in this example, you could see like I have a class called area calculator. So what is the sole purpose of that class is there is a function called area which takes a rectangle object and returns double. So what it does for rectangle area, we calculate by rectangle width, rectangle height, we multiply and return the area. So now I have a class rectangle and my area calculator is, it's a sole purpose of this class is to calculate area. Okay, we'll see once you have one more uh, object, say like I have a rectangle, now I wanted to calculate the area of a circle. So notice now I have a circle class which has a property called radius and it assigns the radius value to it. So now the core part where we wanted our focus to be on the area calculator class, which was accepting only the radius, only the rectangle previously. Now what we do is my area takes shape of any and returns a double. So now since the object is of any type, my area calculator functionality is getting changed. This is the problematic place where which we need to resolve it. So what we are doing is now we wanted to check shape is of type rectangle, shape is of circle, then calculate the area according to that. So what it is doing, why I say this is the problematic place, because tomorrow if you add any other shape, so let's take an example and we assume we add triangle. Now my area calculator check will keep on increasing. So what I am trying to do is I am not keeping my class open for modification, whereas what I am trying to do is I am keep on adding the new things in the class which I should avoid it. We'll understand like how we can avoid this in the next slide. So we understood the problem because the problem was the area calculator class was keep on adding the multiple functionalities, or the it has to identify the shape and then uh, after that it has to work on it. So what we were doing is we were changing the core class. How we can now avoid this using interfaces which are called protocols. So assume look into the very first part. We have created a protocol shape and which has a method called area and which returns double. Now any shape which I create, so the very first example we took, we have a rectangle will conform to shape and it will implement the area method of its own. With this what is happening is my area calculator class is concise. What it is doing is it takes the shape which is the shape protocol object and then it calls that specific object's area method. So if you conform to this protocol, you need to implement the area method and area calculator will work as smooth as possible. Now tomorrow assume I wanted to add a triangle. So how the triangle functionality, it will conform to the shape protocol. My area calculator class I am not changing. Before closing this topic, I wanted to quickly run through one more example. So let's get in. So this is the example where like you have a customer and a premium customer. So you wanted to calculate the discount percentage on the top of it. So I have not mentioned a class, maybe a base class from where the customer and the premium customer is derived. So now what happens is you wanted to give discounts. So now instead of writing that in the parent class, the customer will get this discount and the premium customer will get a 20% discount. What we are going to do is we create a discount protocol, and instead of in the base class, which I forgot to mention, I will add the source code in the description so that it will become more clear. But assume we have a parent class customer from which this customer and the premium customer, the normal customer and the premium customer is derived. And then instead of your customer should get discount and the type of customer, if the customer is a normal customer or the premium customer, the type of discount should be implemented here itself, and how it can be achieved by using protocols. So this is it for today. If you have liked the video, please leave a thumbs up, and if you feel the content is helpful to you, please hit the subscribe button, and if you have any queries, please let me know in the comment section. So this is it for today. I'll see you in my next video. Bye bye.